Dear student, greetings for the season. Today we will study about nylon synthetic fiber. In 1927, the DuPont Company gave a small group of scientists unrestricted funds for basic research in the hope that new scientific information would ultimately lead to chemical advancement. A year later, the research team headed by Wallace Carothers began to study long-chain molecules similar to those found in natural fibers, rubber and plastic products. Dr. Carothers was interested in obtaining a better understanding of polymerization. He wanted to know how and why certain molecules join to form giant molecules. After many months of research, one of Dr. Carothers' assistants discovered that one polymer could be drawn out into a long fiber. When it was cooled, the fiber could be drawn out further to several times its original length. This strand was strong, lustrous, pliable and silky. During the next several years, research with a series of polyamides continued. In February 1935, one of these was made from hexampheline diamine and adipic acid. The polymer is called 6,6 because each of these component chemical compounds contains 6 carbon atoms per molecule. Nylon was announced in 1938 and the first nylon products produced were a nylon bristle toothbrush made with nylon yarn and women's stockings. Nylon was the genuine synthetic fiber to be commercialized in 1939. It is frequently referred to as polyamide, as the repeating units are linked by amide bonds. Later nylon 6 fiber was developed. Today the major production in the United States is nylon 6,6 with less production of nylon 6. The major type produced in other countries is nylon 6. Definition: defines nylon fiber as a manufactured fiber in which the fiber-forming substance is a long-chain synthetic polymer in which less than 85% of the amide linkages are attached directly to two aromatic rings. Nylon is a generic designation for a family of synthetic polymers, based on aliphatic or semi-aromatic polyamides. Nylon is a thermoplastic silky material that can be melt-processed into fibers, films, or shapes. It is made of repeating units linked by amide links similar to the peptide bonds in proteins. Nylons are polyamides. The recurring amide groups contain the elements carbon, oxygen, and hydrogen. The molecular chains of nylon have no side chains or cross linkages. Cold drawing aligns the chains to become oriented with the fiber axis and improves the tenacity. Staple fibers meant for blending with other fibers are not cold drawn after spinning as they do not require higher tenacity. The two most common versions of nylon are nylon 6,6, polyhexampheline adiamide, and nylon 6, polycaprolactam, a cyclic nylon intermediate. The raw materials for nylon are derived from petroleum byproducts. Types of nylon: two most important types of nylon produced are nylon 6,6, nylon 6 in nylon polymer 6,6. The number 6 indicates the number of carbon atoms in each of the two chemical compounds from which the polymer is made. Nylon 6 is made from a single compound containing 6 carbon atoms. The nylon fiber made by DuPont is made from Nylon 6,6 polymer. The raw material used for the manufacture of nylon, namely hexamphenyl diamine and adipic acid, are made to react in an autoclave, which is like a huge pressure cooker, in order to form the amide polymer. The polymer is extruded in ribbon form, which may be made into either chips or pellets. The polymer chips collected from various autoclaves are mixed together in a hopper to ensure homogeneity. Thoroughly mixed pellets are made to fall on a hot grid, thereby melting the polymer. This molten solution is called dope solution. To this dope solution, titanium dioxide is added if luster is to be controlled. Sometimes dyes are also added to the dope solution if colored fibers are to be produced. The solution is filtered to remove solid impurities like semi-solid degraded polymer or metal pieces. The solution is vacuum treated to remove air bubbles. Filtration and vacuum treatment ensures continuous filament and reduces the frequency of nubs. The dope solution is then forced through a spinneret into a cool chamber, which solidifies the filaments. The filaments are then cold drawn to orient the molecules to the fiber axis. This process increases fiber fineness and strength. The drawn filaments are given a slight twist. Filament fibers are drawn 4 to 5 times their original length. They can then be heat set for dimensional stability and wound onto bobbins. Staple fibers are drawn, crimped and heat set, cut to the desired length and baled. Nylon is available in various forms: multifilament, monofilament, staple, dough. Fibers are produced in bright, semi-dull and dull lusters. The fiber performance is influenced by fiber shape. The trilobal nylon fibers are used for carpets and square fibers with voids that give good soil-hiding characteristics. These fibers are cylindrical in shape, with smooth surfaces and without having any markings. The fibers are uniform in diameter and appear round in cross-section. Regular nylon has a round cross-section and is perfectly uniform throughout the filament. Microscopically, the fibers look like fine glass rods. They are transparent unless they have been delustered or solution dyed. Nylon burns with difficulty. Fabric shrinks, forming black incrushable beads. Physical properties of nylon fabric's strength. Nylon has good tenacity and regarded as the strongest textile fiber. Weight to weight, nylon filament is stronger than steel wire. Nylon has a high strength to weight ratio. Because of its excellent strength, nylon is added at the points of wear such as knees and seats of jeans and toes and heels of socks. The strength of the nylon fabric is lost when wet. Density. The fiber is regarded as one of the lightest fibers with 1.15 specific gravity. Added to the lightweight, high strength of the fiber makes it suitable for automobile and other industrial applications. Elasticity. Nylon has good elasticity, which means it is more flexible. Nylon materials return to their original length after stretching and shed the wrinkles or creases. Hence, it is suitable for the apparel purposes, more so for hosiery. Nylon hosiery recovers to its original shape at knees and ankles instead of bagging. Resilience. Nylon fabrics have excellent resilience. Nylon fabrics retain their smooth appearance and the wrinkles from the usual daily activities can be removed easily. Drapability. Nylon filament fabrics have excellent draping qualities, which vary depending on the yarn size. The lightweight sheer fabrics of nylon nightgowns have high draping quality. The medium-weight dress fabrics can drape very well. Heat conductivity. The heat conductivity of the nylon fabrics vary depending upon the fabric construction, the type of nylon, staple/filament, used in the construction, etc. For instance, the filament nylon used in the open construction would be cooler when compared to the same filament used in a closed construction. In a closed or tight construction, the air circulation through the fabric is limited. The heat and moisture of the body will not readily pass the fabric construction, which makes the wearer feel very warm. Such fabrics are good for winter apparel, such as windbreakers, but are not suitable for summer garments. On the other hand, the fabrics with open construction permits the air circulation, which make the wearer feel cool. Absorbency. Nylon fabrics have low absorbency, so water remains on the surface of the fabrics and runs off the smooth fabric and hence dries quickly. This property makes the nylon fabrics suitable for raincoats and shower curtains. Nylon's low absorbency has a disadvantage in that the fabric feels clammy and uncomfortable in warm, humid weather. Cleanliness and washability. Nylon fabrics are considered as easy care fabrics. Nylon fabrics are smooth, non-absorbent and dry quickly. Dirt doesn't cling to this smooth fiber, so can be cleaned by using a damp cloth. Nylon whites are commonly referred as color scavengers. They should be washed separately to avoid graying because they easily take up color and dirt from the wash water. Nylon garments not only retain their appearance during wear, but also retain their appearance and shape after washing. However, hot water should be avoided during washing as it may cause wrinkling in some fabric constructions. Shrinkage. Nylon fabrics retain their shape and appearance after washing. It has good stability and does not shrink. Effect of heat. Nylon should always be ironed at low temperatures. Using hot iron will result in glazing and then melting of the fabric. Effect of light. Nylon fabrics have low resistance to sunlight. They are not suitable for curtains or draperies as it is weakened by the exposure to sunlight. Resistance to mildew. Nylon fabrics have absolute resistance to the development of mildew. Resistance to insects. Nylon is resistant to moths and fungi. Resistance to perspiration. Nylon fabrics are resistant to perspiration. Effect of bleaches. The nylon fabrics are white and generally do not require bleaching. The nylon fabrics which pick up color or develop graying should be bleached with oxidizing bleaches such as hydrogen peroxide. Reaction to alkalis. Nylon has excellent resistance to alkalis, but frequent and prolonged exposures will weaken the fabrics. Reaction to acids. Nylon is less resistant to the action of acids and is damaged by strong acids. Affinity for dyes. Nylon can be easily dyed with a wider range of dyes. The dyed fabrics retain their color and have good resistance to fading. Hosiery. Nylon is used to make track pants, shorts, swimwear, activewear, windshields, bedspread and draperies. It can also be made into combat uniforms and life vests. It is also used as the netting of bridal veils, umbrellas and luggage. 2. Nylon fiber. Nylon is used to make toothbrush bristles, fishing lines, nets, carpet fiber, airbag fiber, auto parts, slings and ropes used in climbing gear, machine parts such as gears and bearings, parachutes, metallized nylon balloons. 3. Clothing. Nylon is used to make pantyhose, socks, ski wear, swimsuits, sportswear, casual wear, lingerie, women's underwear, rainwear, linings, etc. 4. Home uses. Cloth for bags, cover cloth for futon, Japanese bedding, furoshiki, square cloth for wrapping things, cloth for umbrella, sewing threads, interlinings, etc. 5. home furnishing, carpets, automotive rugs, upholstery, artificial turfs, rugs, etc. 6. Industrial uses: tire cords, automotive airbags, fishing nets, fishing line, computer ribbon, hoses, industrial sewing thread, footwear, automotive furnishings, substrate for synthetic leather, etc. Anti-static finish, for reduction of electrostatic buildup, embossing, for pattern or design heat setting, for permanent shape moiring, for shimmer effect molding, for shaping fabrics in different patterns such as pleated form nylonizing, for increased absorbency, water repellency, for added protection against water. Textile industry is one of the major applications for nylon fibers market. Nylon is favored by consumer because of the following reasons: high strength, hence used for a wide range of applications in the automobile and textile industries. Good wear resistance, used in manufacture of synthetic carpets. Good resilience, used in stockings and lingerie. Easy to care for, can be machine washed and dried, although low heat is recommended during ironing. Can be heat set, pleats and creases can be heat set at higher temperatures. Excellent abrasion resistance. High resistance to insects, fungi, animals, as well as molds, mildew, rot and many chemicals. Nylon is blended with wool or rayon to increase the strength, resistance to wear and tear. There are different nylon blends available in the market: nylon and cotton, nylon and wool, nylon and silk, nylon and rayon, nylon and acetate, nylon and triacetate. Care of nylon garment: machine wash in cold water. Wash it separately from other types of fabric. If needed, use only non-chlorine bleach to bleach nylon garments. Turn the setting to low before tumbling dry. Nylon fabrics should be ironed at the low temperature. Nylon tends to become discolored by poor washing methods. Lack of frequent washings. Pickup of color during washing. Use of excessive heat. Absorption of oily soil into fiber.